My name's Peter Gaynord. I'm a full-time general class teacher at a large junior school in Cambridge. Last summer I was appointed as a CAS master teacher, and Phil's asked me to come down here and give a session on logo. Now, following on from what was said this morning, I have to say right at the beginning, I probably wouldn't make logo. I'm not suggesting for 1 minute that logo becomes your main language in your primary school. Definitely scratch. But what I'm showing you today is like condensed Campbell's soup thrown at you really quickly. Mostly you playing on your laptops, but you could actually stretch what I show you today out into easily half a term's work for a group of children. Okay? So if you want to contact me, that's my school email address, which is completely unmemorable. I also have a CAS web address. If you go to the CAS website and you put if you've registered and you put my name in, you can also get a much simpler email address from that website for me. And you can also look at some of the resources that we put on the website. So the internet search engines this morning, I've recently put a resource on there that's a series of lessons, plans, and it's got video of my lovely year 3s doing how search engines work with string and sort of laminated cards and little hats for spider bots when they went off and made all the connections for the indexes. And there's some really good stuff on the CAS website, so if you're not a member, I really urge you to become one. I imagine because you're here today, you're probably mostly members, aren't you? I'm probably preaching to the converted. So let's have a look at logo. What I want you to get from the session is to get some ideas for teaching in your classrooms and using logo.
Oh, thank you. Sets here, but we only have sets at the moment.
Okay.
We're using our
that's fantastic. That's okay. Cheers, thank you. So something concrete you can take away, and I'll talk about which areas of the computing curriculum this tool can address, and some of the terminology, because it's really important. Some of the terminology is a bit phasing when you look at abstraction and decomposition, but we'll talk about that as we go through it. Brief history of logo. I sort of stole this off the internet, and what it says, logo's been around for a long time, late 1960s. It was born from a bunch of researchers in MIT in America who were looking at artificial intelligence, and a spin-off of their work that they were doing was they created this language for children that really makes you focus and think about drawing, because you're actually programming almost like a remote pencil to do the drawing for you. It became a turtle over time because apparently their floor robots had a big dome on top and looked like a turtle. So traditionally, a lot of logo platforms that you can purchase have a turtle. Now there are lots of different platforms. There's we use Texties in our school. That's a very good one. Logotron have got one. There's certainly another one that somebody showed me the other day. And they all have a lot of bells and whistles added to the basic programming language, and they're not bad. But some of those bells and whistles, I find certainly with the Texties one that we've got, there's stuff that you'd probably be better off doing with the ProBots. So I would start work with ProBots and certainly B-Bots lower down the school before you went to logo, because I think logo follows on very naturally from those tools, those kind of roamers. Okay. The reason I'm doing logo is I wanted to show you how to do this. This is what my children did in year 5 last year. You definitely get a big wow moment in your classroom from logo because it's visual. Yeah, it's a programming tool that once, if you steer them through a series of lessons over a course of time, you can reach this kind of level of sophistication in terms of what you can produce. And when the children produce something like that, you really get a kind of like, wow, you can hear it in the room. Okay, so those are patterns that they managed to draw with logo. Okay, so we're going to learn how to move around the screen, how to draw, and then we're going to move on to how we repeat actions and how we decompose a big problem into smaller chunks. So for now, what I'd like you to do, that's it for the PowerPoint, by the way. That next slide was my final slide, you'll be relieved to know. So I'll just kill the PowerPoint. What I'd like you to do is if you could all pull up FSM logo, so hopefully you've got something on your screens that looks a bit like mine. Okay, so you get this blank screen. Now the handout I've got for you has got some very useful websites. It's got certain filter coded websites. It's got like a fireworks program that he's done with Logo, and it's got all the steps and the instructions for doing that. I've put the ITT website on there, as well as the CAS website. The ITT website is very good. It's aimed at trainees, but it's got so much. What they've done for them is they've put the program of study, and they've sort of hyperlinked all the words, so that when you click on them, you go straight to like a bit of video or a resource for teaching that particular part of the study. These are all on your handout, but will be coming around. Okay, so the first thing I want to show you is the different parts of the screen. This is really the output area where the turtle actually, the turtle, by the way, in this free version, that I chose today because you've all got this in your schools. When you go back, it's freebie, it's off the internet. It's based on what was Microsoft Windows logo, and it's just got a bit more of a user interface around it. You can type in commands into this line at the bottom. If it doesn't like what you're doing, it gives you sort of error messages over here. There's a few buttons over there. And so we're going to start really basic. I'm going to teach you just 3 commands. Forward, which abbreviates to FD, and you can forward 100 and draw a line. You can right turn or left turn, and you can specify an angle. So if I do a right turn 90, my turtle's now pointing to the wall over there. Now when you've done some drawing, if you get a bit, if you want to start again, CS is a clear screen. So my challenge for you is you've got 5 minutes to see how many polygons you can draw with your turtle just using those basic commands. Perhaps start with a 3-sided polygon and then a 4-sided polygon and make your way up.
Yeah, right.
Off you go.
Go for it.
Cheers, Phil.
Proper copies.
Quite a guy, thanks.
That's what I have done,
Now, right,
So if we did, what is it? Forward.
right, 90, and then repeat. 3. Not enough inputs to repeat.
Maybe repeat forward 100. Okay, so it's done it once.
I didn't notice.
Yeah, it's done it once.
Oh, so you did it once, but you didn't tell it to do more than once. So what, to repeat? 2?
2 forward 100.
Oh,
No.
But that's because I didn't turn instead. I went forward
Yeah,
again.
so
So actually, let's do a rectangle instead. So repeat 2, right 90, forward 100.
I'll see if I can get Russell up
I don't
another
want it
one
to
for
repeat
you.
2 though, do I? I just want it to repeat because I then need to. Then I need to forward 100, right 90, forward 200.
So that's it.
Okay, you can tell them.
Yeah, we'll try.
Oh, I realised that exactly.
Who's managed to draw a triangle? Well done. Who's managed to do a square? Well done. Pentagon? Oh, not one person in the last group managed a pentagon, which is obviously the advanced group. Well done. Well, I'd like you to just stop there if you could and just get your attention again. With children with logo, I probably wouldn't go straight into this kind of thing immediately. I mean, I'd probably get them to just draw randomly on the screen first. And then there's all sorts of exercises you can pull off the internet where they follow, and that's a nice gentle way in. what I'm kind of doing with you is accelerating you through an exercise that you probably do over a number of weeks. Okay? So you just investigated polygons. There's a couple of key concepts here. The first one is, with children, if you get two children and you get one to mirror the other, and you say, okay, 2 steps forward, left turn 90 degrees, and one just does the turns on the same spot and doesn't move. So he's turning the same as me, but I'm actually moving as well. If you say to a class of young children, like, who turned the most, they always say the person who walked. They think turning's got something to do with the movement and not just the rotation. So your maths in this is all about turning is about rotation. And when you're drawing your shapes of the turtle, you're actually telling it what the external angle is, aren't you, each time? Does anybody want to suggest, let's see if this group's the advanced group, what might be the rule for the amount of turn you do for any sided polygon?
It's the number of sides. So the magic number is 360.
It's 360.
Divided by how many sides you want.
Well done. Divided by the number of sides. Because if the turtle ends up facing in the direction he started in, with your commands, he's always gone through 360 degrees. And if you experiment and you investigate this enough, you work out pretty soon that the turn each time for a regular polygon is 360 divided by the number of sides. So for a square, it's 360 divided by 4, which comes to 90 degrees. So we can use that information now. I'm going to move into decomposition now rapidly. What I want to do, I want to write a piece of logo code that draws a flower. And I mean flower in a kind of loose sense, because each petal of this flower is actually going to be a polygon. Okay, so what we're going to start with is we're going to decompose the problem. Instead of going for flower to start off with, let's see if we can draw a petal. Can we write a piece of code that, using that piece of maths knowledge about 360 divided by the number of sides, to draw any kind of polygon? It'll actually draw the polygon we tell it to. We'll specify the number of sides. We'll say I want a 3-sided polygon, a 5-sided polygon, and we're going to write that piece of code now. Now in a logo, you can do something you can't do in Scratch. You can actually write procedures. And procedures are a great way of doing decomposition. In Scratch, you can't kind of write one block that's called by another block. But in Logo, you can. So what we're setting off to do here is we're going to write eventually a flower procedure that calls a petal procedure. Let's start with just the petal procedure. And the way you do that is if you click on the button in the bottom right corner, the Ed All, I think that stands for Edit All, and at the top it's come up with the template for a logo procedure now, and it says to an end. And what I'm going to do is just put a couple of blank lines in there, and I'm going to call my procedure to petal. Okay? And because we're accelerating here, I'm also going to introduce this idea of what are called parameters. They're kind of distant cousins of variables. And parameters are pieces of information that you can pass into a procedure that it then uses to control what it does. And the 2 pieces of information I'm going to pass in are, one, the number of sides, because that tells me how much the turtle's got to turn, but also, because I'm being fancy, I'm going to put in the length of each side, because it'd be nice to control how big the petal is and how long it is. So I'm going to put parameters in. And the way you do that is you have to put a colon, and I'm going to put colon size, and then I'm going to put colon sides. And they actually stand for the size and the number of sides. Okay. Now, I didn't give you a chance to play with this, but when you drew your square, how many forward commands did you have? 4. You can actually do a repeat command in Logo, so you don't end up with strings of commands that are all the same. So we're going to use the repeat command. And there was one student at the back who immediately, having been told 3 commands in Logo, asked me how she finds out more commands. And I would probably have done this with the children right at the beginning. Very, very, very early on, I'd shown them this thing called Help Facility. And if you click on Help and you go to Index, it's a very unusual help facility in FMS Logo because it's actually quite helpful. And it's got a list of commands. And one of the commands in there is the repeat command. And if you look up a command, it usually gives you a sort of synopsis of the command, a shortcut for the command, or a shortened version if there is one, and then it usually gives you an example of how you would use it. Okay, so we're going to use the repeat command. So that's just introducing the help facility to you. So if you minimise that, I'm going to use repeat. I'm going to say repeat, and the number of times I want the number of sides on my petal is the number of times I'm going to repeat. Now, because I'm telling it, I want to do that at a number of times that's controlled by that parameter that we give to it when we run it. So when we run this procedure called petal, I'm going to tell it how many sides. So at that moment in time, sides will have a value. It will be like 4, 5, 3. But in order to tell the program what you're doing, you have to put the co on. You have to keep the co on. That's how you tell it. It's like a parameter is kind of distant cousin of a variable. So repeat sides, and then the repeat command has open square brackets, and I'm going to do my forward first. And my forward isn't going to be like 100 or 200, it's actually going to be size, and that's going to change every time I run the procedure. And then I'm going to do a right turn, and this is the really fancy bit of code now. This is what you've got to build up with the children over a series of lessons with rulers and turn, and seeing if I bet some of the children in your class, like my class, can work that rule out. They've worked out that rule that it's 360 divided by the number of sides for a polygon, and that's like a sort of like a mini maths investigation built into your computer science, isn't it? So right turn 360. And the syntax for that is that divide, there isn't a divide sign, you just put the slash, and then it's 360 divided by sides. Okay? So, we've written a procedure called petal. It accepts two pieces of information, the size of the petal and the number of sides, and it uses this repeat command, which is like condensed through, to actually draw a polygon now for us. And when you're happy with your procedure, you do File, Save and Exit. If you've made any mistakes at that point, it often now tells you and says, oh, you missed the bracket off the end of here. Because somebody speaking earlier today did say they weren't using Python in their school because it's not a block language like Scratch, and that makes it too difficult. The children don't get beyond the problems of typing it in. And that's not really been my experience in our school. I mean, we are opposite the Cambridge Science part, and 3/4 of my class do have mums and dads who are scientists and programmers. But certainly, I'm being honest with you, you know. But so if I run that code now, petal. Well, what I've got to tell petal now is the length of my side. I'll say 200. Number of sides, let's say 6, and it draws me a hexagon. So can you have a go now at writing your own procedure and logo called petal? And if you finish early, tinker. If you need help, put your hand up. Okay. So we've got a piece of code that's quite handy. Get rid of that. We can draw any kind of petal. We can draw 3 sides, 200. That was interesting. Did you notice what it did? That's an investigation in its own right. What's it drawn now? Is it a circle? What's a circle? Has a circle got 200 sides? This is, we had one of those days, I don't know what your schools are like, but in our school we get these kind of things where somebody will sort of say in a meeting, guys, by Friday all display boards changed in the corridors. Yeah, I don't know what your schools are like, but that happens in our school. And this time I thought, let's do some logo programming. So the theme was mathematics. They said the display boards had to be mathematics. So I got my year 3 class to do a maths investigation using logo. Now it was Text's logo, which is a little bit easier to use than FSM. But all the same, all they did, the only hope I had was that they could investigate how to draw a square. And they actually some of them went way past that. They did like triangles, squares, and they just kind of coloured them in, and then copied them somewhere and wrote a sentence underneath like, we discovered to draw a square that you have to move the turtle 90 degrees, you know, and it was a really lovely session. And that circle one is an interesting one, because is it a circle, you know, so you can do a lot of math stuff with logo. But moving this along now, in terms of our decomposition, we've written a logo command now called petal, which is a really powerful, flexible logo command that can draw any polygon, any size. So all I'm going to do now is imagine like a sort of computer-type flower that's made up of those petals. Okay? So what do we actually want to do in terms of how are we going to evenly spread a number of petals around in a circle? Does anybody know what we should perhaps turn the turtle after drawing each single petal? Has anybody got any
Whatever
ideas?
we want, it could be 45, 90, depending on...
Think bigger, think more flexible, even more flexible. What if there's 6 petals, 8 petals, 12 petals, 14 petals? So, however many petals you've got, divide that into 360 and they'll be evenly spaced around the flower. So that's another big step, okay? So I'm going to write my flower procedure now. And this is something you can't really do in Scratch, but Logo really does this decomposition. So you can now call your command, your petal command, from another procedure. So I'm going to write another procedure called toFlower. And all it's going to do is it's going to have the same list of parameters. So we're going to have size and sides, but it's also now going to have petals. Okay, I'm going to call it num-petals, because the last group, somebody had to go about petals and petals, they're a bit too similar, aren't they? The procedure is called petal, this procedure is called flower, and it's got a parameter called num-petals. Okay, and with children you can make those names so that they're not confusing. Okay, so if you make them a bit longer, so I'll call it num-petals this time. Okay, so all we're going to do is repeat, and we're going to call, how many times are we going to repeat? We're going to repeat num-petals, and we're going to, what are we actually going to repeat? We're going to do petal, and we're going to pass into petal what it's expecting, which is size first, and then sides, and then, in fact that's it, that's what we're going to do, and we're going to call it like that. And what we've got to do next, anybody want to have a guess? We've got to do right turn, 360, divided by, and it's num-petals. Okay, quick look at the code, does it look okay? Save and exit. By the way, Logo is more challenging than Scratch without a doubt, because on that last piece of code, let's say I forgot to put the right turn in. I put the angle in, rather than put the RT right turn command. Sometimes with Logo, the error messages that you then get, if I run flower, and I say, right, I want 100 as the length, 5 is the number of sides, and I want 12 petals. It didn't work, and it gives me this error message. It says, you don't say what to do with 72 in repeat sides, and that sounds a bit confusing, doesn't it, actually? But what it's doing is being very clever. It's telling me, in my code, it worked out that 360 divided by the number of sides was 72 degrees. But he didn't know what to do with that value 72, because I didn't tell it. What I wanted to do was right turn. So if I put that command in now, and run it again, so if I do flower, 100, 5, 12, it's now working. So, well, it's question time. I'll show you a bit of tinkering in a little while, but have a little play with that and see if you can write your own flower procedure, because what you can do now, so flower, 100, let's say 5 sides, we'll do 20 petals. Right, it didn't work, did it? Okay, so let's do a bit of cooking. Mr. Gaynord, why didn't it work? Anybody want to tell me why it's not working?
Yeah.
It's very subtle.
Because you've told it to turn 360 degrees, so it is doing it, but it's going over itself. Right.
You're warmish. Have a look at the end of the line where non-petal is and compare that to the end of the line in the petal procedure. What did I forget to put on the end of that repeat command? Close square bracket. And that's all I got, as my code wasn't working. So if you really want to teach your children some good debugging skills, Logo is a good language for that. Sorry?
You've put it after sides.
Put it in the wrong place, that's it. Sorry, I didn't notice that one. I put it there, I put it there, there, instead of there, okay? So what it was actually doing is repeating, just calling petal to just draw the same petal over and over. So it wasn't doing the rotation. I put the rotation outside the square bracket. So let's see if we've debugged it. Do a clear screen, we'll do flower. Let's do the same one, 100, 5, 20. Okay, happy days. Have a go, see if you can get your flower working. Who's ready for a bit of tinkering? Should we do a bit of tinkering, just to make this a bit more whammy for the children? Right. Okay, got the code. Right, I showed you the help facility. And some of the things you can do is you can set a pen colour, you can set a pen size. So if you look that up, set. In fact, if you do set, you get all the set commands. So set pen colour, and it's a simple enough command. You do set pen colour, and then you give it a colour. If you look at using colour though, it gives you a list of colours in this list, and it's like 0 to 15. They're all those colours. So if I do set pen colour 14, I'll get orange. If I do set pen colour lime, number 2, I'll get lime. So you can do, and there's a set pen size command. So you can do, just let me get that out of the way. You can do set pen size. If I do set, you can't see what I'm typing now, can you? If I do set pen colour. In fact, there's an abbreviation for that command. It told me it was set PC, the pen colour, and I can give it a number. So I'll give it like 13. So I've set a pen colour now. So if I run my flower now, let's go for 20, 12 sides, and let's do 30 petals, indecisive. Okay, so we've got something that's a bit more colourful. You can increase the pen size. You can do set pen size. Pen, can't spell it. Set pen size. And I can make the pen a little bit chunkier. I think normally it's like 1, so I can set it up. You can do set pen colour. Let's go for, right, what was red? Fancy red. 4. Oh yeah, thank you. So set pen colour 4. Yes. And this time I'm going to do flower. We'll go for 200. Go for 6 sides, and we'll do 5. I don't know what it's going to look like. Okay. But what you can do is you can create a pattern where you now do different layers. Okay. I want you to do that as a tinkering. Have a little tinker with that. But if you want a really advanced tinker, if I was doing logo with children, I quite often show them like the random function. In fact, any programming language, I always show them the random function, because nobody quite knows what's going to come out of the program if you've got random in it. So what I'm going to do is just very quickly, and then I really just want you to finish the session with some tinkering before I close up. But inside my flower procedure, I'm just curious now, I'm just playing, I'm wondering what it would look like in my repeat if I did set pen colour, and instead of choosing a colour myself, I said random. Now you can look these commands up, but random has round brackets, and you just give it the number that it's choosing, a random number. So it's going to choose a random number between 1 and 15. Okay. So I've just changed the pan colour. Okay. So let's see what effect that has. So if I do clear screen, set pan size, flower. Let's go for 100. 8, and we'll go for 20. Okay. So, a bit more wowy. The children do love like something that produces like a graphical output. This is where they really get enthused by programming. When I did logo in my class for my year 5s, when they produced these patterns, each time there was a kind of like audible sort of wow. Yeah? But they did those by doing what you're about to do, but layering one flower on top of another, okay? And then they put them in PowerPoint, did all sorts of fancy backgrounds and things. So have a go with that last piece of tinkering.
Sorry,
Shall I put my code?
How did you make the brown?
I mean, I hope you've got lots of ideas from today. Like I say, start simple. Can they draw patterns on the screen? Can you draw like a house with a little roof? Yeah, just draw it. Can you then move it into polygons? And then right at the end, the whole sort of procedure stuff I've just shown you, that decomposition, that's pretty advanced stuff. And if you build slowly, you can do it. And I think you can see that some of your class will latch onto that like that. Some won't get it. But if you support them, you know, the ones who find it really difficult, then they'll still get the same patterns and the same output. So, you've got your packs, it's got lots of really good websites on there. Do have a look at them and search the internet. You search for MSW logo or FSM logo. There's lots of great ideas to do. And if you want to drop me an email anytime to query me, please do. But I hope you have some fun with your children doing logo. And it's legal now, we can do computer science. You don't have to say it's art or maths. Okay, thank you very much for coming.
Thank you.
Thank you.